This lesson is an important topic in trigonometry, and it's known as the law of cosines. And before going through the video, let's first check to see if maybe you already know the law of cosines. So here are two questions that require knowing the law of cosines to answer. So let me put them up for you. So these are two of the sorts of questions you do with the law of cosines. In question number one, we're told that in this triangle, AC is 8 centimeters, CB is 6 centimeters, and the angle C here is 75 degrees. And their question is, can you figure out the length of side AB if you have those three pieces of information? Law of cosines also gets used if you have a triangle, like in number 2, where you know the three sides of the triangle. In this case, AC is 8 centimeters, BC is 6 centimeters, and that third side, AB, is 11.25 centimeters. And using those three pieces of information, can you figure out the number of degrees of this angle, or any of the angles, but for this question, of that angle? So before you start this lesson, why don't you first take a moment to see if you already know how to do these two questions. If not, you can push the button to just move on with the lesson, or you can check your answers. So take a few minutes to look at that, or push the button to continue. So the answers to the two questions: for number 1, it's approximately 8.67 centimeters, and for number 2, it's approximately x equals 106 degrees. If you got these two answers, you already know the law of cosines, or you were a very good guesser. Either way, you can proceed to some new topic. But if you didn't get one or both of these answers, I'm going to teach you how to answer a question like number 1, first by just using some trigonometry that you may have already learned, and then we'll derive something called the law of cosines, which enables you to answer a question like number 1 very quickly. Take about 30 seconds to answer question number 1 with the law of cosines formula, and take a little bit longer, a couple of minutes, but you'd be able to do question number 2 using that same formula. The law of cosines is used primarily when you have two sides and the angle in between them, like we do in example number 1. We use it to find the missing side. Or like in example 2, if we know all three sides of a triangle, we can use the law of cosines to find any of the angles that we want. One observation before we start is that there's a very special case of this sort of situation where we have two sides and the angle in between them, which would not require the law of cosines. And that would be the situation where the angle was not 75 degrees, but where the angle was exactly 90 degrees. If the angle is 90 degrees, we would be able to use what's called the Pythagorean theorem. So the Pythagorean theorem says that if we have a right triangle, the relationship between the three sides is that a squared plus b squared is equal to c squared. With this problem, a is the side across from angle A, so a would be 6. B would be the side across from angle B, which in this case is 8. And C would be the side across from the right angle, which is the unknown in this case. So according to the Pythagorean theorem, 6 squared plus 8 squared would be equal to c squared. 6 squared is 36. 8 squared is 64 equals c squared. 36 plus 64 is 100, which is c squared, which means that the length of side AB, which is also called side lowercase c, would be exactly 10 centimeters, which is the answer. Now, in the law of cosines, the angle is no longer 90 degrees. If the angle is 90 degrees, you'd use the Pythagorean theorem. But if the angle were bigger than 90 degrees, maybe 110, or if the angle is less than 90 degrees, like 75, well, now side AB will not be 10 anymore. And I'm going to have you take a minute just to ponder this. If the angle was 90 degrees, AB would be 10. So Is there any conclusion that you can make about AB? Maybe it's not the exact length of AB, but some sort of observation or conjecture or hypothesis about the length of AB. Take a minute to think about that for a minute. What might you say about the side of AB if the angle is not 90 degrees, but it's less than 90 degrees, such as 75? And I hope you said something like that the side should be less than 10, which would be accurate. It turns out to be about 8.67. So once again, now I'll leave the length up there. When the angle was 90 degrees, the side was exactly 10 because of the Pythagorean theorem. When the angle gets less than 90, it's kind of like imagine that AB is kind of like a rubber band, that as that angle gets smaller, AB kind of shrinks to make up for it. AB will be less than 10. And in situations where the angle is bigger than 90 degrees, it sort of stretches out that side AB, and now AB is bigger than 10. Those are just some things that I want you to think about as we ponder problems like this. Now, before we're ready to tackle question number 1 without using the law of cosines, but just by doing it with math you have already learned, I want to review sort of a prerequisite skill, which is this. Here I have a right triangle, and I know the side AC, the large side, the hypotenuse, is equal to 8 centimeters, and I know this angle here, angle C, is 75 degrees. And with that information, I want to see, is it possible to figure out the length of the other two sides? And that is something that you can do using what's called right triangle trigonometry, and I'll show you how that works. So if I want to figure out what x is, I'm going to use the property that sine of an angle, which in this case is 75 degrees, sine of a 75 degree angle is equal to the opposite side over the hypotenuse. We say equals opposite over hypotenuse. There are going to be other tutorials that describe this right triangle trigonometry in more detail. This is just a review. The opposite is x, the hypotenuse is 8. So then if I multiply both sides by 8, I learn that x is equal to 8 times sine of 75 degrees. If I go over to my calculator, eight times sine of 75 degrees becomes 7.73 approximately. Centimeters, that is. If I want to figure out what y is, I have two choices now. I could use Pythagorean theorem because I know two sides of the right triangle, or I could use the fact that the cosine of 75 degrees is equal to whatever the length of the adjacent side is over the hypotenuse, the big side. The adjacent side is the y that I don't know. The hypotenuse is 8. If I multiply both sides by 8, I learn that y is equal to 8 times cosine of 75, which, according to my calculator, 8 times cosine 75 becomes 2.07 approximately centimeters. And that's the prerequisite skills we need to be able to do a question like the original question number 1 without using the law of cosines. Then we will get an actual formula which allows you to answer the question even without knowing this stuff. But this is good to know for understanding where the formula comes from. If you would like to do another practice question on this type of thing, we have CA is 8 centimeters, and we're asking you to find what the length of AB is in this case, and also what BC is. So if you want to take a moment to work out those, or you could just push skip to the next thing. So for the for the x value, you do the equation sine 50 equals x over 8, or x equals 8 sine 50, which is approximately 6.13. Whereas to get the y value, we would use cosine 50 equals y over 8, or y equals 8 cosine 50, and 8 cosine 50 is approximately 5.14. Well, we'll be using this in doing problem number 1 the long way, then we'll get a shortcut for it. So let's use some of these ideas to revisit question 1 from before. We want to know how big AB is when we know that AC is 8, BC is 6, angle ACB is 75. Also from before, established that if ACB was 90, x would be 10, but it's not 90, it's less than 90, and x is going to be something less than 10. But what exactly? Well, one way to do this without using a fancy formula is to draw what's called an altitude from point A perpendicular to side BC. What this does is it splits this triangle into two right triangles. And the idea is, if I can somehow, I'll call this point D here, if I could somehow figure out how big AD is and how big side BD is in that right-hand right triangle, I could use the Pythagorean theorem to get x. Well, AD we can get because AD, from our example before, this is the 75, the triangle from before with the 75-degree angle and the 8 centimeters. So AD ends up becoming 8 sine 75 degrees, which is 7.73 approximately. So that one is 7.73. Now we need to know how big BD is. The way we're going to get BD is by first figuring out how big CD is. Well, CD is the adjacent side to angle 75, and if you look at the example from before where we just had the right triangle, this was the same numbers. CD ended up becoming 8 cosine 75, which is 3.93. Well, that 3.93 can help us get side BD because the entire BC side is 6. If I subtract 6 minus 3.93, I get 2.07, and that's the length of BD. Now, to get my answer for x, I can use right triangle ADB, or I'll see that x squared is equal to 7.73 squared plus 2 Let's revisit this question now. You have your side that's length 6, the side that's length 8, and your 75-degree angle. Now, one way to do this question would be to draw from an altitude, which is a line perpendicular to another side of a triangle, which would split up this triangle into two different right triangles. And our goal is to figure out the length of AB. So if we could somehow figure out the length of, I'll call this D, of AD and BD, then I could use Pythagorean theorem to figure out the length of x. Well, this triangle on the left, ACD, is the triangle I worked with before that had a 75-degree angle and a hypotenuse side AC of 8. You can go back to look at that. What happened when we did that is that AD became 8 sine 75, which became 7.73 approximately. And CD became 8 cosine 75, which became 2.07 approximately. Well, that's helpful because the 7.73 is side AD, which is one side of this right-hand triangle, whereas side BD can be calculated by subtracting 6 minus 2.07 to get 3.93. So what I have here on the right-hand side is a right triangle, ADB, and if I have a right triangle and I know the two shorter sides, I can work out the longer side through the Pythagorean theorem. When you calculate this all out, you get about 75.1978, and when you take the square root of that, you get 8.67, which is the answer to this question. So you could do it that way, but there's a way to make this even easier by developing a formula. I'm going to show you how that formula comes about, and then we're going to apply it. If instead of doing the actual calculations, I just left stuff like CD, I just left it as 8 cosine 75, or leaving AD as 8 sine 75, I would end up with this answer, which looks pretty ugly. But what I want to show you is that if instead of 8 and 6, these things were called lowercase b, lowercase a, and if instead of 75, I just called it angle C, then my calculations or my answers would be something like this. B cosine C, AD would be B sine C. This would make BD, which is BC minus CD, which would be A minus B cosine C. And now I would have the two shorter sides of the right triangle ADB, so I can say that x squared equals B sine C squared plus A minus B cosine C squared. Still looks pretty ugly, but watch, a nice thing will happen. Well, it looks like it's gotten even uglier. But there is something nice that will happen, which is this. If I rearrange it, and I can factor out the b squared from these second and third terms. And bring this back. There's a rule in math that sine squared c plus cosine squared c is always equal to 1. And with this, we get what's called law of cosines. And this derivation is pretty intimidating, but once the formula has been established, it allows us to answer questions like this much more quickly. So I'm going to apply this question, this formula again, to a similar question. So here's a question perfectly suited for the law of cosines. We know the 8 for AC and the 6 for BC, and this time the angle is 40 degrees. According to the law of cosines, c squared equals a squared plus b squared minus 2 times a times b times cosine c. In this case, a is 6 and b is 8. 8, the same 6 and 8 go in this spot. And now, I'll just do a little bit of this by hand, plus 100 minus 2 times 6 times 8 times cosine 40. If I throw this all into the calculator, okay, I type this all in, I hit enter, get 26.46, which means that if I take the square root of 26.46, square root of the previous answer, I get my answer of 5.14, which is the answer to this question. That's approximately, but it's pretty close. Okay, here's an opportunity for you to do a practice question. Okay, here's the one we just did. I'll hide the answer. We'll ramp this up to be 60 degrees. Too much. Okay, take a minute to try to find the answer for this question. What's AB to the nearest, rounded to the nearest hundredth? Okay, here is the answer, 7.21. Here's another question for you to work on. If I make my angle bigger than 90 degrees, let's say it's 110 degrees. Take a minute to work this question. Something unusual will happen. Okay, the answer to this question ended up becoming bigger than 10, became 11.53. I'll show you the work for that one. So for this one, it's c squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times cosine 110. Now, on our calculator, you'll see that cosine of 110 degrees happens to be negative 0.3420. So this becomes 36 plus 64 minus 96 times negative 0.3420. This negative times this negative becomes positive, and that's why this whole answer ends up being 100 plus whatever 96.3420 is, times 96, 32.83, which is 132.83. On the calculator, I can take the square root of that, and get my answer. That's strange. Let me fix that a little bit. Just type something in there. There's the problem. Why did I multiply that by 96? Cosine of 110 multiplied by 96 became that. I wanted to do 100 minus that. we get 132. And that's the thing I want to take the square root of. Don't know what happened there. You can watch that on your own and see. Get 11.53 as the answer. According to this, 11.53 is the answer to that question. So this law of cosines works for when the angle's not 90 degrees. It works when it's less than 90, or it works when it's greater than 90. Now, there's one question left that gets used in the law of cosines a lot, that you use the law of cosines for a lot, and that is what to do if you have three sides of a triangle and you want to know one of the angles. So let's take a look at one of the questions, sort of diagnostic questions we started with. Here is the situation. We had 6 here, 8 here, 11.25 here. These are all centimeters. And the question was, how big is this missing angle? And the way this works is we can use the formula again. C squared equals A squared plus B squared minus 2AB cosine C. But in this case, the C is already known. The A and B are already known. 2 times 6 times 8. But this C here is the unknown. Now, 11.25 squared happens to be 126.5625. 6 squared plus 8 squared is 36 plus 64, which is 100. 2 times 6 times 8 is 96. Now, a common error that you want to watch out for here is to do 100 minus 96 and get 4, but we don't want to do that. Instead, you want to subtract 100 from both sides. And I'll continue over here. We end up with 26.5625 equals negative 96 cosine C. Now you divide both sides by negative 96. And when you divide this one by negative 96, you end up with negative 0.2767 equals cosine C. So it seems strange to have a negative there, but that happens when cosine is an obtuse angle. So I'll go to my calculator, negative 2.767, and I'll do cosine inverse of negative 0.2767. And as expected, I get an obtuse angle, which is about 106 degrees. So C equals 106 degrees. Okay, let's finish off with one more example of where you have to find the missing angle. One thing to notice about this question is that the letters aren't called A, B, and C anymore, which could be confusing because the law of cosines has A, B, and C in it. Well, when that happens, you could always think of the angle you're trying to find as C, and the side across from it as lowercase c. And then the other two things you could just think of as A and B, and you pretty much ignore whatever letters they put in there. Sometimes they confuse you and put, an A across from the missing angle. I always think of C as the missing angle, or I think of C as the missing side if it's one of the other types of questions. So according to the law of cosines, 11.6 squared equals 10 squared. That's a C squared equals A squared plus B squared, which is 7 squared, minus 2AB, which is minus 2 times 10 times 7, times cosine C, which is still cosine C. Now 11.6 squared is 134.56. 10 squared is 100, 7 squared is 49. So this becomes 149. minus 2 times 10 times 7 is 140 cosine C. Again, don't be tempted to do 149 minus 140. Instead, subtract 149 from both sides to get negative 14.44. This is after taking away 149 from both sides. Equals minus 140 cosine C. Divide both sides by minus 140. To get 0.1031 equals cosine C. And finally, C is cosine inverse of 0.1031, which on the calculator let me type that in. Cosine inverse of 0.1031 ends up becoming 84.1 degrees. Which is the answer to that question. Well, that covers the two types of questions you use the law of cosines for. Looking back at all the stuff we did to get to there, you might recall we began with this. And in learning about the law of cosines, we managed to solve these two questions. The question number 1 on the left, we did a lengthy way by splitting it up into two right triangles. That's the long way. You don't have to do it that way. That was just for the purposes of showing you how the law of cosines is derived. But for our purposes, it's usually important to just be able to apply the law of cosines, and that's where the examples came in at the end. So I hope you enjoyed this lesson and that you learned a lot.